Okay, so it's 6-9, I guess. Participants are increasing. So hello guys, I am Anirudh. I'm a coordinator and project member here at the Computer Vision and Intelligence Club. I'll be taking your first part of the session today, which is arrays. So if I'm audible and you guys can hear me, obviously, please react or just open your mic and speak.
Yeah, you're audible.
Very good. Okay. So a little bit of like little lay of the land before we start. So if more of you open your mic and talk, it's gonna be that much better because if the session goes silent and none of you open your mic and talk, usually the person who's teaching, that's me or Ashish and Gokul who will be taking over, they will also lose their enthusiasm to teach you more. So if you ask me questions, I'll teach you as much as I can. If you don't, then you will end up getting bored and I'll also end up getting bored. Let's not do that. If you can open your mic and speak, that will be amazing. Like, there is no such thing as a bad doubt. The worst thing is not asking any doubts at all. So I would honestly suggest all of you to just open your mic and have full chaos instead of just it being just straight up boring. So is that clear? Open your mics, please. Whoever heard me. Cool. Pranav
Hello.
is in. Yeah. Hello.
There are two links that were shared to us.
Okay.
One in the group
Uh,
that we just got, and one in the mail yesterday. This is the one we got yesterday in the mail.
Okay, I
So,
joined this through the one that was sent in the group. Let me
I
check.
think both are the same links. Can you just check once?
no, when I
Yeah,
tried
1 second.
joining, it sent me to another meeting.
Is that the case? Like, just give me a minute. I'll just check it once. So you might have gotten two links yesterday, one for yesterday's session and one for today, which had like which was a follow up to the same email thread. Maybe is that what you're referring to?
No, the the one that we got in the follow-up email is this meeting's link. The one which I'm opening in the group, I'm being sent to another
Which
meeting.
group are we talking about?
The Freshy Programmers one.
Okay.
Programs.
All
I
right.
mean, during the C5 orientation, we got that link to join
Okay,
the
so maybe
WhatsApp
let's
group.
do one thing. I'll send this meeting's link on this chat. Maybe you can just share it to that group as well so people don't get confused. Is that fine?
Yeah, sure.
Yeah, I think it has been sent.
So they're using the one that was sent on email and on other Freshie groups. So I think someone might have shared the wrong link in that particular group.
Okay.
Okay. Just tell them to join in as quick as possible because they'll be like the learning curve of this session will be like not very steep, but it will be very good if you can stay from the start. I think that is something that is also better. So tell them to join as fast as possible. All right, we have around 20-ish people. We'll get started for now. Let's not get others waiting. As I said, the more you talk to me, the more I'll talk to you. Okay, so I think let's just ensure that is clear. 1 second. Entire screen. Screen. Okay. Is my screen visible, guys?
Yes, it's visible.
Beautiful. Okay. So, Aris, this is where we start getting into what makes
Yeah, Anirudh.
computer science and programming. So, hello. Yeah. Ashish?
Yeah, you might
You
want
saying
to
something?
hide that pop-up in the bottom. There's
Microsoft
one pop-up, right?
Teams.
Yeah, just hide that.
Okay.
Yeah, cool.
Now, my full screen is dead. 1 second. It's fine. Cool. Okay, cool. Is my screen clean and visible now, Ashish?
Yep.
Okay, I'm going to assume it's clean and visible. So, Aris, now we're getting to the part of what makes programming quite interesting. Variables, if else. I think, oh yeah, there's another thing I wanted to get out of the way. You guys are doing CS 1100 and CS 1100 equivalent courses, right? So, can someone help me out with where you guys are in CS 1100 or the equivalent courses?
We are right now in the end of loops. We are just about to start arrays.
Oh, beautiful. So, very plays very well into my hands. Okay, then I will make this as this will. I hope that this will be the best arrays explanation you will get. Of course, it's not hard. I mean, it's not easy to like beat the explanations of procs in general, but okay, I'll try my best. Here we go. What is an array? An array is a collection of similar type of data items stored at contiguous memory locations. That is a formal definition, but the two things I want you to take away from this is similar type and contiguous memory locations. So in general, if you see an array, this is very important to understand that not everything that stores variables together is an array. There are certain restrictions to what we call an array in the most classical sense, which is they have to be of the same data type and they have to be stored right next to each other physically in the memory. You cannot have them randomly everywhere across the memory. I think that much would be clear. You guys are very smart, so fine. Why do we need an array? I think that is something that you have to understand. So can someone, I think we have written something here itself. Every nifty tool or data structure you see today is a solution of a problem that we need to solve at some point. At some point, someone faced an issue and then they decided, okay, let's just approach this problem like this, and our problem will be much simpler to solve, right? So different kinds of variables in data, you have variables. Okay, iterate multiple times over the same piece of code, loops. That is what we discussed all like for yesterday. Those who weren't able to join, I'm sorry, but I don't think if you have come till here, if you have done CS 1100 in general, you wouldn't have missed much in yesterday's session. Need to establish conditional statements. So can someone tell me what problem does an array solve?
Array
Silence is
solves
something
the
that I
problem
do
of
not.
having multiple, like you want to store a set of similar data, that you don't have to create n number of different variables, and we can store it in a single variable.
Yes, definitely. So I think that is something key, right? Which is you don't want to keep multiple, like if you, let us say, want to store a bunch of phone numbers together, you don't want to put phone number one is equal to 995208236, phone number 2 is equal to 8668002. Like you don't want that. Rather, you would like to have some sort of data structure that will just allow you to access everything in one go. It just makes life so much more simpler. In fact, that's most of what these kind of data structures allow you to do. Can you technically live life without loops? Variables you can't, but can you technically live life without loops? Yes. I mean, you just need to copy paste the same code multiple times again and again and again. That makes your coding just look terrible. So loops are just there to clean up and, I mean, sometimes add conditional statements inside them. Conditional statements, of course, we need them, but yeah. So point is, an array, real question you have to ask yourself is, what problem does an array really solve? What does an array bring to the table that you weren't able to achieve before? So let's you group multiple variables of the same data type under one roof or under one big variable. This is of incredible use when you want to group data from the same data type. Okay, so as I said, phone numbers is a good example, names is a good example. Clearly, arrays are huge for several uses, especially use cases involving large amounts of data. So, I mean, if you look at the old days, they started off with just simple addition, and that took like the entire room, right? But then, as you start progressing with computational power and efficiencies in terms of how you compute the code that's given to you, you start realizing that, okay, instead of having 2 variables, I can scale up to 3, 4, 5. And then suddenly you have exponential scaling. And then you realize, okay, fine. Instead of seeing things one-dimensional, I can start seeing things 2-dimensionally, right? So until now, you're seeing things in 1 dimension. But then at some point, you'll realize, okay, you can start getting matrices involved. So you can start, by the way, my whiteboard is visible, right?
Yes.
Like I have shared the entire window. Okay. So until now, you were looking at everything that was going in just 1 dimension. So you had 1, 2, 3, 4, like things like that. Terrible writing, but don't mind that. But then you realize, okay, computers are not powerful enough to open up an entirely new dimension at some point. I think I'm not going to go into exact years, but then you realize, oh, wait, not just 2 dimensions. We can go into 3 dimensions. And then you can go into 4, 5, 6 dimensions, which is humanly not computable. We just cannot wrap our heads around a 4th dimension. But yeah, so I mean, this is just to give you a basic idea of how you can, how basically the problem statement has scaled up, and all of these things that you will be studying are just solutions to these problems that have come up as people have tried to scale up their problem statement in general. So I guess, okay, so Yeah, and also you'll realize multidimensional array helps speed up maths due to the magic of parallel computing. This is something I just want you to keep in mind. If you do deep learning and things like that, you will learn this concept of vectorization, which basically just says that if you do something in a loop, basically what it means is it will not start the next iteration of the loop without finishing the previous iteration. But if let us say you don't necessarily care what happens in the previous iteration to start the next iteration, you can just parallelly compute all of them together. So again, bringing back if you have an array, if you are just looking at one dimension, so if you're looking at a n by one array, then this is just, let us say this has some amount of data and you want to run a loop through this data, and you have, I don't know, m such examples. The initial thought would be to just how do I put it? The initial thought would be to just stack them up vertically. So then you'll finish this, and then you'll do n, and then you'll finish this, and then you'll do n. But this is just severely inefficient time-wise. Rather, you stack them horizontally, and then you run the entire loop once, and that's it. And since processors have gotten really efficient, this is actually much faster. Depending upon your scale of data, this can be like thousands of times faster. Once again, arrays come to use there. But all, like, this is just to give you an idea. We will not be diving into multi-dimensional arrays, or at least in my part. My friends might have come up with it, but I want you to understand that this is a very powerful piece of data type that we start off with. That this is kind of the genesis of what you will be seeing in a lot of data types that come in the future. Am I clear until now? That's a lot of words said by me. I don't want to go on a monologue. Are we clear till now? Hello?
Yes.
Cool. Okay. I guess fine. So we'll start with basic features of an array. This is taken straight from Geeks for Geeks, but it's actually a good explanation of what an array will look like in our heads, at least. Your first index is 0, and you have an index of 10. Notice we actually start from 0. Almost all arrays index from 0. That's just your written rule. Then you'll have 1, 2, 3. Okay. Then after that is just straight up increasing numbers. Element at index 8 is actually your 9th element. And yeah, each of these boxes denote an element in the array. And the key is that these elements are stored right next to each other physically. This makes accessing and indexing any element super quick. Okay. Like, I guess you guys haven't done linked lists yet. But if basically the thing is, if they're right next to each other, the idea is that, wait, hold on. I'll try and bring up my whiteboard. I'm just trying to explain each point so that you understand the importance. Like, if I just tell you this is a game, then that would mean nothing if you don't understand what you are losing until then. So, okay. So if we have little boxes of memories, right? And I have been given this box's address. Okay. So somehow the computer told me that this box's address is some ABCD. It doesn't matter. Now, if I want to access the 4th element, and let us say every box knew where the next box is. Am I being clear until now?
Yeah.
Okay. So you can imagine this is your index 0, this is your index 1, this is your index 2, and this is your index 3. Okay. And we know index 0's address. So the real question is, if let us say we want to access the 3rd element, what we'll have to do is, this is your memory, by the way. Like, this is just like, I don't know, whatever RAM you have. Terrible drawing. Whatever RAM you have, this will be your big RAM, whatever. And this is just bunch of memory. So if you can think 16 GB of memory, then that's 16 into how many 1024. Like, it's huge. But in that, this is stored in very random locations. So what the memory will physically have to do, it will go here, it will check 0. From 0, it will know the location of 1. 0 will contain value of 0 and address of 1. Then it will go here. Then it will go here. Then it will go here. You realize how inefficient this can be. If you want to access the 3rd element, pakka you have to access the 0th, 1st, and 2nd element before you can reach the 3rd element. Is this concept very clear? You don't need to know exactly how this works, but this is one way of actually storing elements next to each other. Because, I mean, ultimately for you, this is technically 0, 1, 2, 3. But this is one way of storing elements together. Is this method basically clear? Like, and understanding how this differs from your usual array.
Is this actually the way that an element like 0 knows the address of the first element?
Yeah, so this is basically your introduction to linked lists. Okay, you will learn all of this in CS 1100. But I want you to understand why arrays are so OP, because you'll need to understand why linked lists. I mean, very basic understanding of how linked lists work. So yeah, zeroth element will contain the value for zeroth element and the address for first element. The reason they do this is because it's easy to insert elements in this. You don't know exactly how, but yeah.
Okay. Okay.
But yeah, does that clear it out?
Yeah.
Okay, cool, wonderful.
Isn't
Please ask
inserting
more
elements-
doubts. More doubts equals.
isn't inserting elements in this linked list so much easier than inserting elements in an array, because if you have to insert elements in an array, we have to copy the array and like create a new array, copy all the elements of the old array.
Yeah,
and then
I'll tell you why. See, if your goal is to only insert elements, I mean, if you know that you will not be indexing elements a lot, like you will not be accessing the third element a lot, the answer really comes down to time complexity. I'll give you that much. What you will realize is it's actually faster to always index the zeroth element than to index the third element. Okay, so if let us say you know the probability of you accessing the zeroth element will be very high compared to the probability of you accessing the third element, a data structure like this will make sense. Okay, but if you know that the probability of you accessing all the elements is equal, so then you will go to something like an array, which is something like this. In the memory, how much or big your pool of memory is, the arrays will be terrible squares. My God, okay, never mind. The arrays will be stored right next to each other like this. And the zeroth element, you know the address to. So this will be a zeroth element. Okay. You realize how ordered this is compared to this. And as Pranav was saying, the only drawback for this is if you want to insert elements, it's a pain. But the pain is worth it, because if let us say you want to access the third element now, you don't need to go to 0, 1, 2, 3. You can just go straight from here to here, because you know this distance and you know this distance. I'm oversimplifying like crazy, but basically this is the idea. You know this, and you know the horizontal, how many bytes you'll have to travel. So you can just directly jump to element number 3, which is much faster. So that is why you have a constant time complexity here. You have a time complexity of n. So that is the reason why sometimes arrays are preferred over linked lists. Once again, I would like you to understand linked lists, because you will understand why arrays are powerful in that sense. Am I being clear till now, or am I going too fast, too slow? Definitely not too slow. I don't get I'm going slow, but yeah. Am I being clear till now?
What's time complexity?
Huh?
What's time complexity?
I couldn't hear you properly. Can you be louder, please?
What is time complexity?
Oh, time complexity. Okay, time complexity is just so time complexity you can think is how long it takes to execute the code. So ideally, if you're developing some sort of a data structure like this, no, you would want to think, okay, fine, I have developed a data structure, but can I do this faster? Because I mean, we always like to do things faster than they already are. I mean, I don't need to tell you guys that you've done JE. So like the point is, you need to really understand, like these are two ways of storing the exact same thing. So I want you to understand the main difference between these two is this is just faster to access compared to this. That's what I mean by time complexity. Is that clear, Anish?
Yeah, yes.
Cool, fine. More doubts, guys. I really appreciate it. So
Can you give an,
okay.
hello?
Huh? Yeah. Go ahead.
Can you give an example where we need to use linked lists and not arrays?
Beautiful. Yeah. Okay. Let's say you're Google. Okay. I don't know if Google uses linked lists. Probably not. They have very developed people working on various things. But let's say you're working on a scale as large as Google. Okay. You have to have like a million different how do I say account details stored in a big list. They don't do this, but I'm to give you an idea of why linked lists are better. If let us say you want to insert an element into an array. Okay, let us say I'm saying this is 0, this is 1, this is 2, this is 4, and this is 5. Okay. Pretend this is a number 2. Okay, now it's a number 2. So what I want you to understand is, let us say I want element number 6 to go in here. Now, notice, oh, okay. This brings me on to a point which I should have explained. I don't know if that's supposed to come earlier, but I'll just quickly tell you this, which is an array in the classic sense is a static array, which means if let's say you tell the computer reserve space, this should make sense now that I've explained the linked list to you. See, notice that this is actually just a grid in the middle of nowhere, right? Like you agree. So there will be some memory, random memory here. This is pure garbage. But the computer is using this much memory. So you have asked the computer only to reserve this much memory for your array. Is this clear? The diagram is looking more and more messy as I go, but I think still the problem statement is being told properly. This is your array, but you realize that immediately to the left of this, the computer is using something. Immediately to the right of this, the computer is using something. Is that what's being transferred? Like, are you clear with that?
Yeah.
Yeah. So which means if let us say you want to insert an element, you realize there's something here and there's something here. Which means, as Pranav was saying earlier, what you'll actually have to do is you have to tell the computer destroy a whole bunch of memory somewhere randomly, like here, and then create 6 spaces for me. So then when I do this, I have a whole new array with 6 spaces, blah, 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 6 spaces. So then what I will do, I'll copy everything here. I'll copy the 0th element, first element, second element, and then the 6th element, and then I'll copy the rest. Okay. This is what I will do if I want to insert an element in an array, which is static. So which means you tell the computer, hey, give me 5 spaces worth of array. Then it will basically just clear out 5 spaces and give you those 5 spaces. If you ask for a 6th space, it will have to go somewhere else, clear out 6 spaces, take everything that it has in these 5 spaces, and then while it's adding them, just inserting this in the middle. So you realize this can be quite cumbersome. Every single time you want to expand the array by 1 or X number of spaces. I think when Ashish takes lists, he might tell you that you can just directly add them in Python, but that's a completely different thing. Lists in Python are not arrays in your classic terms. So if anybody who has familiarity in Python is thinking like this is not like a list, that's because lists are actually not arrays in the classical sense. It's like a whole bunch of functions attached to an array. That's just for those who have familiarity in Python. If you don't, beautiful. Because basically what I'm teaching you is what you'll be learning in CS 1100. So, I mean, RG, those who didn't come. Just kidding. So yeah, basically what I'm saying is, if you take like this is very cumbersome. Every single time you have to insert an element. With a linked list, you just need to change these arrows. Anyways, these are random. So what I'll do is if I want to insert the 6th element between the 2nd and the 3rd, I'll erase this lane. And then I'll just say, this will be my 6th element. And then this will be my 3rd element. You realize how much time I've saved by just inserting an element randomly in some space and just pointing whichever is searching, pointing the memory, you just go check here. So, I mean, you have to gain some, you have to lose some. So in an array, you gain in indexing. Indexing is super quick. But modifying the array, especially when if you're expanding the size of the array, is very difficult in terms of time. Whereas in a linked list, it's so much easy to insert stuff. But now if I want to index what is in number 3, I have to start from 0, 1, 2, 3. It's like a shuttle run every single time, which is not very efficient. Is that understood?
Yeah, but when we will copy the array into the new expanded array, will the old array of 5 elements be still there, or will it be completely destroyed?
It depends. So basically, if let us say you are copying the array into a new variable, okay, you're initializing a new array and then you're doing it, it's fine. But if you are so usually you can't just insert things. You will have to initialize a different array. So there is actually there's something called malloc. So what C does exactly with this array, to just keep it in this case, because you will do this manually. I'm talking about C. Why I'm talking about C is you guys are doing CS 1100 and your primary language is C, right? I don't know, they didn't change anything. You are learning C in CS 1100, right?
Yes.
Yeah.
Beautiful. So I will be explaining things with C because C is the most basic, most classical implementation of all data types. Everything else adds a layer of human understanding on C. So C is actually the best way to start off with programming. And it implements arrays in the most classical sense. you would actually have to do this by yourself. You'll have to start a separate array, and then you'll have to kind of add elements in this if you want to insert a different element. There might be a function to this. I'm not very proficient in C as per se, but this is the way you will do it. So basically, what this will mean is this will be some A2, and A1 will just be chilling. If you want to get rid of A1 and free up that space, you can do it, but you have to use this function called malloc, which is, I mean, honestly, if the computer feels like, if the computer, once you close this program, it will just erase it by itself. But yeah, for the timing, to answer your question, yes, both of these arrays will actually exist parallelly because you have actually given them two separate variables when you're implementing this. Can you?
Yeah, got it.
Got it?
Hmm.
Anything else?
No, thank you.
Okay. Yeah. Feel free to open your mic and ask doubts anytime. It's very fun. See, the conversations are so much more fun than monologues.
Is there any way to have a mixture of linked list and array? Like, can we have best of both? Or is it not physically?
Hold on to the thought. You tell me whether that's possible after I'm done with this presentation. I think you should be able to answer that question by yourself. So wait, let's see. Basic features of arrays, because I don't want to overextend my time. You guys are set for a long session, so let's just make this as concise as possible wherever I can. Form of arrays we'll be looking at today, static arrays. These arrays cannot change their shape once initialized. So in that insert case, if let us say you want to, for some reason, stick with these 5 elements, then you have to nuke one element, basically destroy, delete it, and then put this in its place. That you can do. Arrays can be multidimensional. However, we will stick to one-dimensional array because in like for multidimensional arrays, I mean, you know, they're just basically matrices, multidimensional arrays. I've even thrown in a matrix for PTSD for those who did J. So, I mean, of course, everyone did J. Anyway, basic features of an array. How do you access an array? Arrays can be accessed by indexing. If we have an array A 1, 2, 3, 4, 5, we can access the element 3 by using the following notation. Element number 3 is equal to A of 2. Is square brackets will contain the index number of the element you would want to access. So wait, let me get a new diagram. This should be pretty simple. So basically, you'd want to yeah. See, all you'd want to do here is yeah. So basically, if we are checking this out, this will be A of 0. This will be A of 1, and so on. You use square brackets. Are there other ways to access it? Yes. At least in C, you can access it using a concept called pointers. But for now, I want you to understand that this is the most classical way to access an array. And I mean, there's really no reason why you shouldn't use this. This is very easy to use. A of 0, first element, A of 1, second element, and things like that. I think indexing is pretty self-explanatory. It's just an implementation. So is that bit clear?
Yes.
I mean, anything? Okay, cool. Is everyone else also clear? Anyone else can open their mic and say yes, I can move on. Yes. Okay, cool. So I mean, this is pretty simple. Implementing arrays. Okay. So there are a couple of tiny quirks and features that I want you to understand with arrays in general, which is first of all, just go through whatever you see. You guys, okay, you did CS 1100, so you need to be able to read hexadecimal. So the code is I think large enough for me to read. So I guess you guys will also be able to read it. If not, I think Teams allows you to zoom. So just zoom and check what I've written. I have given it a very large number. So see, one way you can like not deal with the insertion problem is just over allocating to begin with. So see, I have done only 6 elements, but I've actually allocated 11 spaces. So now you have noticed that in C at least, you see I've written int A of 11. What does this actually mean? I'll bring this out into whiteboard so that I can explain this. It's very crucial in terms of implementation, and I want you to understand why it's important. So see, in general, each one of these has a meaning. Every syntax in any programming language has a meaning. Otherwise, it wouldn't be there. So what does this 11 mean? This 11 means 11 integers possible. Okay. So this box that I showed is actually the space it takes to store one integer. So if I put 5, how much of a space 5 takes, that is the equivalent of this box. And you guys would have read that one integer takes 4 bytes. Do you guys know this? One integer is actually 4 bytes. Is that known? You don't need to know this, but it would make my explanation easier. So if you don't know it, well, you know now. One integer takes 4 bytes in always. So int a of 11, basically you're telling C, I'm initializing a variable called, which will be of the integer data type, and it will be called a, and it will have 11 it can have 11 integers in it. So when C reads this, what it will do, it will actually do 11 into 4, and it will see I need to clear out 44 bytes. So imagine it's just like it's going to a place, terrible handwriting, my god. It's just going to a place and just basically just deleting whatever was in that RAM, most will be garbage values, and then just reserving a fresh base of like 44 bytes in this case, out of which you can use, I'm using how many? 24 only. I'm having 6 elements, each of 4 bytes. I'm using only 24, but it has reserved this space also. So this space is not garbage anymore. Over allocating is a way to kind of combat that extreme burden of like at least copying elements. You just have to shift here. So that is what I've done. Now what I've written is the address of the third location of the array is, have you guys done data types? You guys know what percentage %p is, right?
Pointer.
Yeah, okay, beautiful. So what I'm doing, I'm saying, give me the location of this third element of the array. That is understood with the syntax, right? A of 2 is just an element, right? You guys know that and A of 2 gives the address of that particular variable, right? I think this was thought. Trying to shuffle my memory here, but A of 2 is nothing but some random, like you can literally put x equal to A of 2. So then this is as good as saying and x. This will not necessarily give the same answer, but I just want you to understand. This will basically give you the location of A. Okay. So again, so I want you to, is this bit understood? So size of one integer of value is size of, I have written third location and fourth location. So is the syntax of declaring an array clear? I'm just helping you guys out here. So not necessarily a part of what I'm teaching, but I think it will be useful because you guys are anyways yet to learn array. Is this part clear? Syntax of declaring an array.
Regarding the initialization, like if you give int a of 11 equal to only 6 values, then will the remaining values still have garbage, or will it initialize to?
No, it will be set to 0. It will be set to 0. If you're initializing, I'm telling you, it's like C will go, it'll look at what it has. There'll be a bunch of garbage there. It'll just clean it out and make it ready for you to use. Think of it like that. It's a very crude explanation, but it's nice to think of C as some human being. I mean, the compile, why not? So if you look at the answers, you will realize these two, 8 to C. How many bytes difference is C minus 8 in hexadecimal? Yes.
So 4.
Just look at C and 8. Everything else is the same if you look at. So just C and 8. C minus 8 is in hexa?
12. C is 12.
C is 12. 8 is 8. So 12 minus 8 is 4. So, I mean, this should give you the exact ideology that C basically stores things right next to each other. That's the main thing I wanted to show you in this. Again, the size of, I also included the size of one integer is 4 bytes, location of the array, and the first element of the array. Make what you will from there. Any doubts in the slide? I think this is an implementation slide, so I would expect you guys to have doubts.
What is %1?
Percentage I, that's I.
Okay.
I don't know if I can zoom in. That's I. Integer. Any doubts?
Can you explain %p? I don't know about pointers.
Okay. So I have like 5 minutes. So a pointer is just a variable. See, if I want to tell you where this is, hexa is, I can't just, okay, like how will I ask C? C is one of the nice languages that actually tells you where it stores everything. So that way it's actually nice. Once again, why I wanted to use C, which is, see, notice that I have used this hexa right here. This is the address. How will I talk to C in a language which understands addresses? Percentage P is that data type which basically communicates in hexadecimal. Integer communicates in integer, float communicates in float. So percentage P is a pointer variable which will give you actual addresses of where it's storing everything, physical addresses. So that kind of bridges the gap between hardware and software, you can say, this particular variable. Is that clear? It's just a variable. I mean, it's just a data type that tells you where everything is physically stored.
Okay.
Clear? Cool. I mean, you can. I mean, all of you guys are free to call. I mean, call me, the message and call, and just ask me any doubts after the session. Because I think we are running a bit late. So yeah, again, before we conclude, just know that character arrays exist. So instead of integers, substitute character. Notice it's only character, not a sentence. So if, let us say, I were to put so the way you will do this is when you initialize the array and you give it a word, it will split every letter of the word into a separate element in the character array. So that's just something you just need to remember. It's pretty simple. Like, it's pretty simple because you guys just study integers. Multi-dimensional array, I think I've spoken enough about multi-dimensional arrays, but know that arrays can be more than one dimension. C allows up to 32 dimensions. This is something my CS 1100 prof told me. So yeah, 32 dimensions is the maximum you can go with C. I don't know if the others one allows for others allow. If we have time, I'll be giving you this in general. I'll give you the what do you say, this PDF by the end of the session. Just try and do this. You guys know loops. You guys know everything till loops. So this is definitely doable. It's a very simple program. Your labs will probably have similar programs as this. But before we conclude, I just want to talk about what kind of data type is an array variable. This is something I wanted to ask, and with this we will conclude our session today. My session. Others will join. Gokul, I think, will take over after this. So one of you, I think there are 39 plus a bunch of circles. I'm not going to count. One of you tell me what kind of a variable is, what kind of a data type is array? What does the array itself stand for?
Is it a string?
Okay, why would you say it's a string?
Because string is like a collection of characters, and array is also a collection of characters.
Okay, so I mean, would you see that as a string being an array or an array being a string? Which one is the actual original?
I'm actually confused, but I think I'm wrong. I think array.
No, it's fine. You. I mean, if you're confused, which means I can help you out. No, I actually have a job to do here. If you're going to read something, that's why I'm here. So beautiful. Point is, actually, a string is basically like an array. It just houses a bunch of characters together and squeezes them together and prints them out. So actually, an array is kind of top of all. So actually, a string is an array. So yes, a string is an array, a type of an array. A string is basically like a word, and a word can be split into a bunch of, that's what a character array is. I've talked about it here. No? A character array is basically a full array with every letter of it being an element. So if I put hello, hello will just be H, E, L, L, O. That will be an array, and your string will be hello. I guess, I don't know if we did this in CS 1100 at this time, but you guys will learn about it in the future. So it's not a string. So what else can it be? We have definitely discussed this data type right now. It's definitely not beyond your purview. So anyone else fancy a chance?
It's a pointer.
Yes, that's correct. It is a pointer. I've given you multiple hints throughout this presentation, actually. Notice how location of the array is basically just the address of the first element. 0x7ffc 52c 572a0 0xx. But just look at the numbers. I'm not going to say these numbers twice, but look at them. They're exactly the same. And also notice I have done this particular graphic. A points to a of 0. Why this makes sense? Because we know the size of the array, and we know, as I've given here, we know where A starts. So we can access any element with just knowing where the first element is. So the job of A is to just point to where the first element is. This is clear.
Yes.
With that, I think we can conclude. Gokul, are you taking over next? Wait. Before that, I'll give you just a minute. Questions? Any questions in general? I've tried my best. We don't have much time, so 2 minutes max. Please feel free to open your mic. It'll be nice.
I did not understand in one of those slides you have used percentage I for an integer. Shouldn't it be percentage
Yes.
D?
No, percentage I also works. I think what is B? Can you remind me what B is again? I think unsigned and signed.
Decimal?
I think that's the difference.
Okay.
Okay. So see, the thing with C is I remember this. There is D, B, and I. The differences between them are unsigned and signed. So I is unsigned integer, which means that I don't think percentage I can show negative. Don't take my word for this. These are little theory that I've forgotten since trimester 3. But percentage I is an unsigned integer. It's actually not advisable to use percentage I, but since I know size of is a positive value, I've used percentage I here. But this also works. This is the output for this. This code compiled. There's nothing wrong with this code. So okay, fine.
Can
Yeah.
you use percentage X instead of percentage P? Can we just print that address as a hexadecimal using percentage X?
I don't think you can because percentage P specifically requests a pointer. So when you tell, see, there are a lot of ways I can possibly check later and tell you in chat because we're running out of time and I have to open a compiler. I'll tell you percentage X works, but my intuition will be it will not because hexadecimal is not necessary. A pointer is a hexadecimal, but every hexadecimal is not a pointer. So I will check and let you know. Sounds good?
Yeah, sure.
Okay, guys. So that's been it from my side. Yeah. Tell.
Yeah, indexing, is it necessary? Because I have learned somewhere that there are two types of indexed errors and arrays and this associative arrays.
What arrays?
Associated arrays.
Associated. No, this is only an indexed array. So these are the arrays which you definitely need indexing for. I'm not. When I did this, I have definitely used indexed arrays. Associated arrays, I'm not precisely sure about. This you definitely need indexing. Is this the only way to index? No, you can index using pointers. But right now, you guys have not done pointers, so that's late. But A of 0, A of 3, A of 2 is the way you can index arrays. I'll get back to you on associated arrays, but not this. You will need indexing for.
Okay.
Cool, fine. That's definitely been an interactive session. Thank you, guys. Thank you for being a good audience. Gokul, I think are you next?
Yeah. So, thank you.
Okay, cool. So I'll stop my screen share and you can start.
Yeah, fine.
Thank you, guys.
So I'll share my screen now. Just let me know if you can. Is it visible?
Hey, Gokul, your audio is very feeble. Drop.
Oh, am I audible now? Sorry.
Yes.
So yeah, is my screen visible?
No,
It's not visible.
I can't see it. Yes. Not sure about the others.
No,
One
not
second.
visible.
1 second. Yeah, is it visible now?
No.
Is it
No.
not? Okay, so I'll just leave the meet and join again, I guess. Is that just give me 2 minutes. I'll just leave the meet and join again, maybe. Then it might start. So am I audible now?
Yes.
And is my screen visible? Can someone confirm now?
Yeah, now it's visible.
Oh yeah.
Oh, yes,
Is it?
it's the
It's visible, right?
Yeah, it's visible.
Yeah. So sorry for that. I'll just carry on now. So intro to Python. So I just heard that you guys already started CS 1100 courses and all the related courses as well. So yeah, that makes my job a lot easier here. So intro to Python. This was supposed to be the starting of the session today, but because of the cyclone yesterday, we weren't able to complete the session yesterday. So yeah. So anyways, uh, let's start. So what is Python? Python is it's a high-level programming language. It was created by someone called the Guido van Rossum in the early 1990s, I guess, if I'm not wrong. Now he works for Microsoft apparently. Yeah, so good for him. So why Python? Like, why a new language? Why not? Why can't we do whatever we want using C++ and Java and all the existing languages? So some of the pluses of Python are that Python is very easy to learn, and it has a much simpler syntax than all the other languages. And Python is also easier to debug, I guess, other than compared to C++ and Java. And Python also has a lot of libraries which make our lives easier as we start writing complicated codes, right? So, and Python is not a perfect language, right? So it must have some disadvantages as well. So one such disadvantage is that Python is relatively slow compared to the other languages, C++ and Java. So I told you guys that Python is easy to debug and it's slower, right? So actually, there is a common reason for these two facts, basically. So the thing is, Python is an interpreter based language, right? And all the other languages, C++ and Java, are compiler based languages. So uh, in interpreter based languages, what happens is that the interpreter takes the Python file, reads the file line by line, and if it encounters a mistake, it points it out then and there, and you'll be able to correct it, and then only you'll be able to run the further uh, code you have. So it's easier to debug that way, and it's slow because you need to the interpreter should be there in the memory for the whole period of the program, basically, which is not the case in the case of compiler. So yeah, I think I just threw away some complex terms. So if you feel that those terms are a bit intimidating, I think those are just basic. You can just Google as well. And if you have any doubt, you can definitely ask me or anyone else. So yeah, if you have any doubt, just unmute and ask, and or you can put in the chat as well. But it's better for you guys to but it's better for me as well as for you guys to if you unmute and ask your doubts as you did in the past half an hour, I guess. So yeah, any doubts so far? Okay, no, I'll take that as a no. So yeah, we'll directly go on to implementing some stuff. All right, so hello, well, everyone must have I'm sure all of you must have printed this command in printed this hello world in any programming language. So printing your first hello world is always a pleasure, I guess. So yeah, we'll I'll one second. Sorry. Uh, I'll go on to the collab notebook now. So this is basically a collab notebook, and this is a bit different from all the IDEs that you guys might have been using till now. Collab notebooks allow you to write code in blocks and run the blocks separately as well. So collab notebooks are easier if you're trying to implement big projects and stuff. So yeah. So this is the syntax of the print function. The print function allows you to display messages on the output device, which is the monitor in your case.
Can we access this file? Sorry to interrupt.
Sorry?
Can we access this file, like this Colab notebook, whatever you're showing?
Yeah. We'll share the Colab notebook as well. We'll share the Colab notebook and the slides as well at the end of the session. So you guys can look it up anytime you want. To create a notebook of your own, you can just open your Google account and go to the Colab website and just click on new notebook and just start typing. That's it. You can even add notes like these, not just the code as well. So that makes it look more neat than just adding comments as well, I guess. So yeah, is that fine? Pranav, I guess.
Thank you. Yeah, it's fine.
Yeah, fine. So the print function, as with the case of any other function, has arguments basically. So if you just type print open brackets and type in a string within the double quotes and close the bracket, and you run it, you just get the string whatever you've written in the output file basically. So one more thing you can do is you can replace the double quotes using single quotes, and it doesn't make any difference. It's still the same, but try not to do this a single quote at the starting and the double quote at the end. Like, try to be consistent. If you open with a single quote, close it with a single quote. If you open it with a double quote, close it with a double quote as well. So this would generate an error, I guess. Yeah, see. So yeah. So that we have our hello world, and we can use the print function to obviously print variables as well. That's a pretty important task, right? Printing variables. Without printing variables, there won't be any point, I guess. So yeah. I just wrote print of a comma b, and I'll just this command will just print both the values of the variable separated by a space. And as you can see, I didn't type any new line character, but it goes to the next line automatically to execute the next print statement, right? So this is the first print statement. It prints in the first line, and then it inserts a new line character in itself, and then it goes on to the next block of code basically. So yeah, here in this print function, there is a square of and comma b comma is comma a, and you get square of 3 is 9. And this is another way of typing. This is another way of printing outputs as well, I guess. This is called this method is called using f strings, and you just type in a f here, and then you write the whole sentence, and you just write all the variables within curly braces so that their value actually gets printed instead of just b. All right, is that fine? If you have any doubts, you can ask now. So I'll actually just go a bit more into the print function. So you can basically type in another argument as well, which is the sep argument, and you can type whatever you want. Basically, let's say I type star, right? Now if I run, both the variables are now separated by stars, as you can see. So that is the use of sep. Usually by default, it's a space, as you just saw. By default, it's just space, 9 space 3. If you write sep equal to star, star and you get 9 and 3. So this is a more syntax oriented session. So just keep track of whatever is going on. And there's one more thing as well I would like to tell it to you guys. So we can also modify. I told you guys that we don't need to insert any new line character, and it inserts the new line character at the end of the print statement by itself, right? We can change what the we can change the basically I just said that after the end of after the end of the print statement, a character gets appended, right? And that is the new line character by default. If I want it to be something like a percent or something, I won't get a new line. Like this print statement is not getting printed in a new line, right? But instead a percent is getting printed, and this just basically separates different print statements. So any doubts here? And if I just write end equal to /n, which is the default, I get a new line. /n is for new line. I hope you guys know it because you guys are already doing CS1100, right? So you guys must be familiar with all this. So any doubts here? Just let me know. Just raise your hand, or better yet, just talk, I guess.
You want to print multiple variables like A, B, C, and then if we give sep equal to, like, let's say if we want to give A star B and then ampersand C, then can we give multiple sep equal to something?
No. It's the same over a print statement. You can't use multiple separate variables, I guess. Is that fine?
Yeah.
I was hoping that you guys would ask me any a particular question, but no one's asking it, so probably I'll just go on here. So if I write a /n here, what do you think will happen? The at the end of O, a new line gets inserted, and the rest of the print statement gets printed in the next line, right? Is that fine? Because the /n is the new line character, a new line is getting inserted at the end of O.
Yeah.
So what if I want to type /n only? Like what if I want to output /n? How do you guys think I can do that? Any idea? I think
backslash.
Yeah, basically backslash, and so I guess I didn't get that out because you guys are probably already familiar with this. So yeah, here you can see you get /n. All right. So that is basically the print statement, and
Hello.
now I would go on to
what are F strings? I think there was something mentioned.
F strings. F strings is just another way of writing the print statement. Like you don't need to put all these commas and write the variable separately outside and all. You can just type in whatever you want and just put all the variables within curly braces, so that it's the same thing here, right? The output of this statement is this. Is that clear?
Yeah, it's clear.
How will we print 9 and 3 together without a space in between?
Without a space in between, just put sep equal to open quote and close quote without anything here, and you'll get 9 and 3 together. Is that fine?
Yeah, got it.
Yeah.
Can it be some string?
Yeah, it can be anything. Sep equal to what do you want? Yeah. Fine. So we'll move on. I think this is a bit more time than I expected to take for print. So data types, right? What are data types? I think you guys are already familiar with variables and data types because you guys are already doing CS1100. I just quickly recap, and I'll give a Python point of view to you guys, so that yeah, you guys gain a new perspective, I guess. So yeah, data types just assign each just give each variable a different certain property, I guess, and using the data type of a variable, you'll be able to identify what operations we can do on that particular variable and so on. So for example, 3.14 is a float and 5 is a int. That's pretty clear, I guess. So yeah, these are the commonly used data types in Python. In numbers, you have int, float, and complex as well. The complex numbers usually we write as 1 + 2i whenever we write in our notebooks and all, but in Python it's 1 plus 2j. Actually, the imaginary number root under -1 is denoted by j. So yeah, keep that in mind as well. So, and we have strings and we have Boolean variables. Boolean variables can have only two values, true or false. I guess you guys know that already. So yeah. And then sequential data types, list, tuple, and sets and dictionaries as well. I think I won't cover much of this because Ashish will be covering regarding these data sets later. So data types later. So now we have okay, I'll just go to the Python notebook as well. So x equal to 10. I'm just this is how you assign a variable. Basically, you don't need to initialize anything. As I told you in the beginning that Python's syntax is way simpler than all the other languages, right? If it's the case of C++, you need to write int x equal to 10 and int a string name equal to student, bool is underscore it underscore any equal to true, and so on. You don't need to write anything here. It just automatically understands that x is an int and name is a string and this variable is a bool. So you can, I'm just printing all the variables here, and this type function will allow you to print the type of the variable basically. So x is an int, right? So you're getting int here, and name is a string, so you're getting string, and this variable is a bool and you get a bool. Yeah, that's basically data types. And now we move on to operators. All right. So any doubts in data sets? Yeah, anything you want to ask? Data types. Okay, no, I guess. So operators, and so basically any a function of a program is to do some operations, right? Without performing any operations, there is no point to any program. So to perform operations, you need operators, and the variables to which you perform operations are called operands. These are basic terms. I hope you guys are familiar with these. So we have mainly three types of operators in Python: the arithmetic operators, the comparison operators, and the logical operators. Arithmetic operators just perform the arithmetic functions: addition, subtraction, division, multiplication. This is the module operator, gives you the remainder, and this is the power operator as well. And you have the comparison operators, which is used to compare two variables. So if two, you can just type in 2 less than 3, and so on. So this is the equality comparator basically. So if you want to check whether two variables are equal, you'll use this. You won't use a single equal to, because a single equal to means you're trying to assign the variable, and a double equal to means you're trying to compare basically. So, and logical operators are used in Boolean literals to find the resulting and, or the or the not basically. So I hope you guys are already familiar with all these. So any doubts you can ask. So yeah, so this is just a basic code. So you'll get a plus b as 11 and so on. So, and one more thing is we have b by 3, right? I'm trying to print b by 3 and I'm getting 2 here, but what if I want to print b by 4? What will I get? I'm getting 1.5, right? But what if I want the floor division value of b by 4? I should use I should use one more slash and I'll get the floor. I'm getting 1 here. So yeah, that's just one observation. That's just one thing you can keep in mind, I guess. And the comparison operators are here. So see, you can compare whether A is equal to B, and A is not equal to B, so you're getting false. And similarly, you can do all these operations. This exclamation equal to is signifies not equal to. So B is not equal to 2. Yeah, B is not equal to 2. So you get true. And yeah, these are just basic, I guess. And yeah, again, a type of compare. This is basically a variable only. This is a Boolean variable, and a type, you get the type of that thing, you get it as bool. So, and logical operators as well. So I told you, right, you get to compare two or more Boolean variables using the logical operators. So a less than b is true, a equal to b is false. So true or false is true, right? I hope you guys know the truth table of or, and not. So that's pretty simple, I guess. And with that, we're done with operators. So any doubts?
Now, a question regarding data types. So, is pointer a valid data type in Python, or is it like entire language runs without pointers?
You don't usually use pointers in Python, as far as I know, but I will just check and let you know in a few minutes after my topics is over in the chat. Is that fine?
Yeah. Can you just ask it again? What did you ask?
I asked if pointers are valid in Python. Is there any?
Yeah, they are valid. The thing is, they are not as useful as C++, because if you take an array, the array elements are stored in a contiguous manner, right? Whereas in Python, they're not. They're stored like randomly. That's why one of the reasons Python is much slower than C++. So as such, there is a notion of pointers, but they are like completely useless.
Yeah. Is that fine?
Yeah, thank you.
Yeah. So now we move on to conditional statements, right? So conditional statements, you make the program decide whether to execute a certain block of code or not. That's the basic point of conditional statements. As mentioned here, it's used in decision making. So there are three keywords in conditional statements: if, elif, and else. And there are three types of conditional statements basically. So there's just an if. You can use just an if statement without any following elif or else. That just determines whether the code block within the code block within the if statement is to be executed based on the condition or not. And the if else, and the next type is the if else statement. You have an if, you have an else. So if the condition is true, the code block within the if is executed. If the condition is false, the code block within the else is executed. And you have if, elif, else ladder basically. So yeah, there's a code block here. So I think I can explain it using this. So yeah, as I told, if and else, right? So if this variable is true, this code is getting printed. Now let's say let's see what happens if this is false. Now this statement is getting executed, right? So yeah, that's basically the point of if else, and this is basically an if else ladder. So if the first variable is true, it'll directly execute the code here. If the first variable is false, but this condition is true, then this will get executed. If both of these are false and then this is true, this code will get executed. If all three of these conditions are false, then this condition will get executed. This code will get executed, right? So yeah, so here true, and false. So summer only is true. So this code is getting executed, as you can see. And what happens if summer is false? Winter will get executed. And if winter is false, all three are false basically. So this code is getting executed. So yeah, that's with conditional statements, I guess. So any doubts here? Okay, I'll take that as a no. So now we move on to looping statements. So
can you repeat what does elif do?
elif, right? Okay. See, this is an if elif else ladder. All right. So first you check this condition. Sorry. First you check this condition, whether if it's true, these code will get executed. All right. This code within the if block will get executed. Now, if this condition, wait, I'll just give number, right? If condition 1 is false and condition 2 is true, this statement will get executed. I'll give a number 2. Sorry. So if condition 1 is false and condition 2 is true, statement 2 will get executed. if both these condition 1 and condition 2 are false, statement 3 will get executed. Is that fine?
Yes.
Yeah. So why do we use loops, right? So if I want to print Python is awesome some 100 times, I can just copy print of Python is awesome, but that takes a lot of time and I'm lazy as well, right? So I don't want to do that. So loops help us out in these kind of conditions. So there are basically two types of loops as in every other language as well. So the for loop and the while loop. So when do you use a for loop? Is that when you know how many iterations you have to run. When you know how many iterations you have to perform the code, then you use a for loop. If you don't know the number of iterations, or if you know when to stop the loop, you can use a while loop. So here are some examples, I guess. Here t equal to 0, while t less than 7, there is a code block here. So what this program does is this while loop. What this while loop does is it executes this code within the while block until this condition is true. Until the condition within the while loop is true, this code block will get executed. All right. So initially t equal to 0, right? So 0 is less than 7, we know. So Python is awesome is getting printed. Okay, one second. So Python is awesome is getting printed. All right. Now t is getting incremented. So t is initially wait, I'll just add t here as well so that you guys can get an idea. So initially t equal to 0 and Python is awesome, comma 0 is getting printed. Now t is getting incremented to 1. All right. Now 1 is also less than 7. So again Python is awesome and 1 will get printed. So this process keep happening till t reaches 7, right? When t equal to 6 comes here, Python is awesome and 6 will get printed. Now t will get incremented to 7, right? Now the program will check whether t is less than 7, but 7 is not less than 7, right? So this condition is violated, so the loop is broken and the program ends. While writing loops, you have to make sure that the program doesn't go into an infinite loop sort of. So basically, if t equal to 7 is here and t plus equal to 2, sorry. It's just getting printed, right? The loop's just going on into an infinite loop. Oh shit. Yeah. Okay, I think that goes on. I'm sorry. So yeah, just make sure that you don't run into trouble like me by running it in an infinite loop. So yeah. Now I just told you the syntax of while loop. Now the syntax for for loop is for I in range of 5, 0, -1 is print. So initially the I will be set to the initial value, and until I reaches the final value, I will get incremented based on this value. So initially I will be 5, and at each iteration I will get incremented by -1, which is equivalent to decrementing I, right? So initially I is 5, now I gets decremented by 1, so I will be 4, and then again decremented by 1, 3, then 2, then 1, then I finally reaches 0. When it reaches 0, the loop breaks. Is that fine? Like, any doubts here? This is the basic syntax of for loop.
There are no opening and closing braces here. So if I want to print something just after the loop ends,
Yeah,
what will
so
I do?
actually I forgot to mention this, but in other languages, indentations are just meant for making the code more readable. But in Python, the indentations are actually important. If you don't indent it properly, you'll get a syntax error. So I don't know, like it depends on IDs as well, I guess. But in my ID, if you don't basically indent properly, you'll get errors. So after the you just want to print, you just want to do something after the loop, right? So just start at the same indentation level as the for loop, and then that would be outside the loop. So A is getting printed only once, right? So is that fine?
Yeah.
Yeah. So that's the syntax of for loop, and while loop as well. So now we go to nested loops. So nested loops are loop within loops. So you x equal to so like I won't explain this code here. So just you just write a for loop inside a for loop. It becomes a nested for loop, right? So I'll try and give you a more interactive problem to solve. So one second. Now let's try to print all these three patterns, I guess. All right, so I think that might be more interesting than just printing some regular programs. So one second. So I think we are also running out of time, so I'll just try to do this very quickly. So by default, the incrementing value is 1. So if you just want it to increment by 1, you don't need to mention that it's 1. All right. So yeah. Yeah, that should be it, I guess. Now you get a star rate. Sorry. And equal to. So now you guys just understood what I just did, right? So the first for loop is for specifying the number of times I want to print this, like, right? So if I put 10 here, I'll get this 10 times. So the first for loop is for the number of times this single line should get printed, and the second for loop is for the number of times this I want number of times I want to print the star in each line. All right. So if I print if I do 7, I'll get more. Initially I had 5, so I'm getting more, right? So yeah, this is basically just a simple syntax for nested loop. So is that understood? Any doubts here? Any doubts how I got this? Like after printing each line, I'm inserting a new line character, because if I don't do this, if I just leave this end, you just saw what happened, right? You won't get it properly, basically. So any doubts here? Any doubts how this code works?
Why you are writing I and J?
Yeah, you can write any variable. This is just a variable name. You can write anything. Fine. Is that clear?
Yeah.
Yeah. Yeah. Go on.
Yeah, okay.
Yeah, fine. So and break and this break and continue as well. These are control. These provide the user to skip through certain block of code of the loop basically. So if you're executing a loop and you just want to break the loop in between, so in this example, the number is initially 5, all right? So the current while number is less than 20, I'm printing the current number and I'm incrementing the number. This is just basic code. So initially 5 will get printed, 6 will get printed, 7 will get printed, and 8 will get printed. When the number becomes 9, all right, when the number becomes 9, I'm using a break statement. So what happens is that this loop just gets breaked, and the the interpreter just goes to the next line, just comes out of the loop. And yeah, that's basically used to stop loops whenever you want, I guess. And continues the it is not the exact opposite, but yeah, kind of a similar operation as well. So here what this code does is that it initially has number equal to 10, and while the number is less than 100, it just keeps increasing the number by 10 uh, at every iteration of the loop. And when the number becomes 50, I'm executing the continue function. So what the continue function does is that it just directly goes from here to the start of the while loop again. It just ignores all the rest of the statements within the loop, basically. So as you can see, initially number is 10, right? So number equal to 10, number 10 is less than 100, and then 10 comes here. So 10 gets doubled, and number will become 20. So this statement will get ignored because 20 is not 50, and I'm printing 20 here. I'm getting 20 here. And similarly, again, the in the next iteration number will be 30, and again the next iteration number will be 40. But when the number is 50, I'm not executing this print file, as you can see, because the because the interpreter directly goes from the continue function to directly the start of the loop again. So on the 50th, when the number equal to 50, this line gets ignored. You can see that, right? You're not getting 50 here anywhere. So that's basically break and continue. So any doubts?
What does semicolon signify over here? I'm sorry, colon.
Colon that's just part of the syntax of the while loop, basically. Syntax of the while loop and the if else statements. So basically in C or C++, you write something like if of I equal to 2 and open curly and close, something like this, right? Instead of this, the syntax here is just using a colon and then going on to the next line. That's just part of the syntax. Don't worry too much about it. Is that clear?
So whenever we have to give a condition, we'll write a for.
Yeah. If that's part of if, elif, else, while, and for. That's it. For and while and if, elif, else. That's it.
Got it.
Yeah. So any more doubts? So no doubts, I guess. But yeah. So basically, this took longer than I expected. So yeah, I think Kishore, you can continue now. Are you there, Kishore?
Yeah. I mean,
Yeah.
so yeah, I guess so. Before we move on to the next part of the session, we'll I think we can take a small 5-minute break. So the time now I say is 7:32. Let's come back at 7:37. Yeah. So meanwhile, you guys can go drink water or something. I mean, audible?
You're audible.
Yeah, good. All right. So yeah, the time now is 7:37. So yeah, I think let's start. So hello guys. I'm Kishore from. I'm a coordinator in Analytics Club and also a project member. So yeah, let's get started this session. So yeah. So now imagine a situation where you have 10 different pairs of numbers and you want to find the sum of those pairs of numbers. So say you have 1, 2, one pair, and 3, 4, 5, 6, and maybe some other random 19, 20, something like that. So yeah, now all the numbers are different. So is there in the usual programming way, what you will do is you'll first maybe assign it to some variables and first calculate 1 plus 2. The next line you will print 2 plus 3 or 3 plus 4, the next pair of numbers or something like that. Or consider another scenario where say you want to check whether a number is odd or even. And yeah, so and say there are like 10 or maybe 100 pairs of 100 numbers. So if you do use the usual, go with usual way of programming, the number of lines of code that you will be using will be very large. So I can show you now. So now, yeah, so that's the problem we are addressing right now. So is there a shorter way to do this, to implement this? And that's where functions come in. So what are functions? So functions are nothing but modules of code that can accomplish a specific task. So they are something like code blocks that you can reuse it whenever you want. So you can they will perform a specific task, and you can insert that block of code uh, wherever you want in your program, and you can reuse it as many times as you want. And functions are just like simple, you can say to some extent, you can compare it with the mathematical functions that you know. So you give an input, you'll get some output, a return, you will get some value as a result. It need not always be a value, as you will see in a few minutes. But yeah, you can also print. Sorry, does anyone have a doubt? All right. Yeah, does anyone have a doubt? If not, you can put some reactions that will like, that will let me know that like I'm not the only one who's talking here.
No.
Cool. Okay, so yeah, now let's look at the let's see the syntax of functions. Let's see how they are implemented in Python. So yeah, so as I was saying, to add two numbers, usually you will do something like this. You will assign to two variables and you will just print them. This one way. Another way is to use something called functions. I will explain in a bit what these words def, return, all mean. So, but for now, yeah, so this is a function, and this will return the value of a plus b. And what I'm doing is I'm printing the value of the result of that function. So if I print it, yeah, there you go, 5. Now, yeah, so right now you can say, why do we need this? So this takes around 4 lines of code, and this thing takes only 3 lines of code. So what is the use of this function? Well, you will appreciate it more when you look at this example. So yeah, so let's take this example. In this example, in this function, so our task is to find whether a number is even or odd. And the way to check it is to divide it by 2, and if the remainder is 0, yeah, it's even, else it's odd. And here I've defined another function that will tell if the number that you pass as input. So here the num that you give here is the input to the function, and it will return either even or odd depending upon the condition. So yeah, and 1 second if I run it, and I want to print the print whether a 4 is a even number or an odd number. So what I do, I take this number 4 and pass it to the function. And it will perform the process, that is, it will divide it by 2 and check if it's even or odd. And I can do the same for number 6 and 5. So if I do that, so there you go. So the output is even, and odd. So what happens here is, forget the print statement for now. Focus on what's inside the print statement. That is only going to get printed. So here I pass the function 4. I mean, they pass the value 4 inside the function. And now this goes inside. And inside we have some statements. And that will check whether, so this statement is an if statement that will check if the number is divisible by 2. And if it's true, yeah, it will return even, else it will return odd. So as you can see, for 3 numbers, it took 3 extra lines apart from these 5 lines. Now, suppose what if I use the usual way of programming? So in that case, what will I do? I will initialize, take a variable, and I will put 4 inside it, and then perform this operation. And yeah, again for 6 I have to do this, and again for 5 I have to do this. So that will be repetitive. So as you can see, it will take twice the number of lines of code as you will need in the case of functions. So here the number of lines of code is definitely higher. You may argue saying that you can use a for loop, which will reduce the number of code, number of lines of code. Well, yeah, that's right. You can reduce it that way also, but there's another reason why we use functions, and that reason is, so suppose say you're calling this function here, and say there are, after this line I have say another set of 4, or say, I think, let's say some random statements, something like Python and some other statement, say 2 plus 3 something, and then I call it again. This, you cannot do this with the for loop. So you cannot have random statements in between. In for loop, it is always how do I say? It is always continuous. So you cannot have random statements in between. But if you define a function, you can call it whenever you want and wherever you want. Wherever you want in the code, you can define a function. You can see this. It'll say even Python 2.3, and then it will still work even and odd. You cannot do this with usual way of programming, that is using a for loop. Or so that's how powerful functions are. And now let's see how we can define this function. Yeah, so till now, is there any doubt? So I guess you understood the why we need a function. All right, so
yes,
yeah, cool, fine. So yeah, so now let's come to the syntax part. So one thing to note here is Python is very similar to English. So in this case, say I want to define a function. So I use a keyword called def. Def, you can expand it to define. So yeah, because Python syntaxes are very similar to English, very similar to the English words. So here I define a function with a function name. This is the function name, and I pass in arguments. These arguments are the input to the function, and this function contains a block of code, and this is the block of code. So there are 4 lines: statement 1, statement 2, statement 3, and return value. So these statement 1, statement 2, statement 3 are any statements, can be anything. And return value is another special statement. This is optional. What this does is it returns a value in the place of function. So I will explain it. I will explain it with an example. You will understand it clearly. And yeah, so that's fine. Now that we have defined this function, how do we use this function? So it's simple. Just write the function name and you pass in the arguments, the inputs that you want. And in that place where the function is in the code, you will get the output of the function. So this return value will appear when you execute the program will appear here. So yeah, I'll explain it with an example. So here, say, yeah, this is another function, left function, f name. So, and now the statement within it is f name plus jr junior. So, yeah, suppose let's say I run it. Yeah. So what happens here is that this function is called 4 times. As you can see, each time the value is different. And say if you were to do this manually, you will have to type this name and junior print and so many times. And suppose say if there are 2 print statements inside the function, you will have twice the number of lines of code than when you use the function. Yeah. So as you can see here, the ML here is a string that goes as input to the function. In the place of f name, ML will go. That will be the input to the function. It's called an argument, and this f name is same as the input f name. That is the argument. So basically, inside the function, that is the code block, when you are using some variables, say something like f name, these variables are have to come from unless you declare it inside the function. If you don't declare it, they have to come from outside the function. So, for example, here f name. So we don't have a value for f name. So if you just simply take this print statement, f name plus junior, that won't make sense. So there has to be some value for f name. So this line makes sense, and that value we will get from the input that we pass to the function. As you can see, when I highlight f name once, yeah, this will also get highlighted. So yeah, we can call it multiple times, and yeah, this is the output. And it is not necessary that we give, so as you have seen here, we give only one input to the function. You can give as many inputs as you want. So yeah, here itself we can see we've given A, B, 2 inputs, and we get one output. And so yeah, here also another example. You give f name, l name, and just run it. Yeah, it will print refness ml according to the values given here. So this will be the first value that'll go to f name, and this will be the second value that'll go to l name. So I have a small question for you guys. So what do you think will happen if I give just one argument? It's a simple question. Hello?
It will give an error.
Right, exactly. It will give an error. So you need two arguments. I will tell you where. I will tell you in a bit where you don't have to give the required number of arguments. So that is also possible. But right now, as you can see, it requires 2 arguments. So now again, if I give 2 arguments, yeah, you'll get the output. So I hope it's clear to you.
Can we give default parameters?
Yes, I'll come to it in a bit. You can. So yeah, till now I hope it's clear. If you have any doubts, you can please feel free to unmute now. All right, so I hope it's clear. Now, yeah, let's go to PPT. Okay, so arguments. So what are arguments? As I said, arguments are the input values that we pass to the function. So here in this case, these values ML, Tobias, Linus, Robert Downey, or here I give 4, 6, 5. In this case here, 2, 1, 3. They are called arguments. And there is something else called parameters. So what are parameters? Parameters are the variables that hold these inputs. So for example, if you see here, in this function, you define the function with these two parameters a and b. And these are not the arguments; these are the parameters. And these you give values to the parameters, which will go inside the function. And so here, there's a return statement here that will give the value of a plus b, and that will be so these two variables are called the parameters, and the 2 and 3 that you pass inside the function are called the arguments. So some people get confused here. So yeah, just to make sure it's clear. All right. Yeah, so we have two types of arguments. Yeah, so like someone pointed out just now, so we have something called the default arguments. And another one is called keyword arguments. So I will quickly explain what these are. Sorry. Yeah. So say suppose you know the value of a parameter. That is, you know what default value that you need to give. Suppose there is no arguments from outside. So in that case, you don't have to specifically mention again and again the the input, because you already know, right? The input that you're going to give. So yeah, in that case, we have something called default arguments, where we can specify the value of the parameter while defining the function itself, and that will be the default value. And so suppose, say, let's say I run this function. As you can see, the outputs are I am from Sweden, corresponding to my function, and when you give Sweden, and I am from India. And when you see a third line, it prints I am from Norway, even though you haven't given any input. And that's because you have already specified that the default value of the parameter, meaning the function will take this value even if you don't give any explicitly mention the value of the give any argument. So yeah, that is the default argument. And yeah, so before going to the next keyword argument, let me ask another simple question. What happens if instead of here I give, so here it's some name refness and ml. So here, let's say I give ml here and refness here. So what do you think will happen? It's a very simple question. What do you think will be the output?
It will be ml and then refness.
Exactly. So it'll be ml and refness. So the thing to notice here is that the ordering is very important. When you change the order of the arguments, the corresponding mapping will also change. So here, so now ml, the value ml goes to fname, and the value refness goes to lname. And so when I print it, it will be fname plus some space plus lname. That will be ml plus space plus lname. So refness here. So that's how it happens. So the ordering is very important here. And suppose say you don't care, you don't want to give the arguments in an ordered fashion. And one way to do this is to use keyword argument. And so here, let's take this example. So here, let's say I have my function name, and child3, child2, and child1 are the parameters of the function. And the statement inside is just a print statement that will print the value inside child3 along with the string, as you can see. So now while calling the function, I pass the arguments this way. Instead of the usual way that I used to do here, I pass it in a different way. So what I do is, so I'll say child1 equals ml, child2 equals Tobias, and child3 equals Linus. So here, as you can see, the ordering is different. Child3, child2, child1 is the order followed in while defining the function. But here, if I give the, if I run the program, you can see the output is the youngest child is Linus. That is the value of child 3. So that's what happened. The child 3, this value is at the end as opposed to the actual order. So when you specify the keywords, the parameters inside the while calling the function, you don't have to care about the order of the or the order in which you pass the arguments. So I hope that's clear.
Instead of putting a plus sign, can we just put comma and write child 3?
Yeah, that will also work. This is called string concatenation. I think you might have studied in CS1 or 1, I'm not sure, but okay, fine. Yeah, we can also do that. That's also the same thing.
Yeah, generally a function performs certain operations. Here appears as if it is just like a variable, because you are just giving values, and the main function is done by printf only.
Yeah. So I've defined the functions that way. So if you want, I can define another function, or here you can see. So here it is performing an operation. So return a plus b, or you can add as many statements as you want. So for instance, say def water operation, say multiply, or maybe you can also print the value of sines, cosines, just like an actual. You can actually make a calculator out of this. You can give the functions that you know in Python. Then you can also get the value. It's not always print statement. Yeah, as you can see here, you can also return the sum of two numbers. Yeah, this is an operation.
Okay.
So I hope that's clear. All right. So it's all about functions. And now just a second. I think. Yeah, so let's go to another topic, classes and objects. So
okay, Kishore, before you move on, just
sorry.
so it's already 8 p.m. So maybe we can ask if they're interested. Okay, guys, so this will take around 10-15 more minutes. Is it fine if we continue this?
Sure.
Okay, so maybe thumbs up from little more, some more people will be. Okay, fine. So great. So yeah, okay, go ahead, Kishore. Sorry.
All right. So yeah, because of time constraint, I'll try to wrap it up as quickly as I can. So I'll go through what classes and objects are. So what are objects? Objects can be anything, just any real life object you can take. So it can be a car, can be a pen, or it can be a laptop that I'm using right now, or the one that you are using, or it can be any real world object, or it can also be abstract. So for instance, so here let's take this car. This car has a car's an object and it has attributes. So one of the attributes is that it is orange in color and it is made of chromium tires. And now let's take this pen. So it is made of iridium. The tip is made of iridium, and this body of the pen is black in color. So yeah, fine. I will tell you why I am talking about objects and classes here in a bit. But yeah, so yeah, these are objects. Basically, thing to note here is objects are any entities that has an attribute, and it can also have methods. So for instance, it can perform some functions basically. So this car here can move forward, or it can take right, or you can basically drive the car. And this pen here the function it performs is it can write. So yeah, that's what objects are. And uh, I will come to the programming aspect of what objects and classes are in a bit. So, and classes. Now, what are classes? Uh, classes are basically the blueprints that we use to make objects. So for example, let's say you want to make a car. How do you need to, how will you make the car? So first, you need a blueprint, and after you make the after you get the blueprint, then you get to decide the color or the brand or say the tires that you're using can be chromium or any other tire, or the color that you want to give. It can be orange like you saw in the previous slide or anything. So basically, classes are blueprints that you can use to make objects. The classes will contain the basic info. So something like color and brand. So you can give the to make an object, you have to use class. So you can make an object out of a class. Basically, you can make a car out with a blueprint. So I hope that's clear. And basically, classes are made of two things. So they will have the fields, that is the color of the car. Like uh, you will have the color of the car in the blueprint, but you will give the actual color, the value of the attribute when you're defining the when you're making the car, when you're actually making the car. You won't just like decide the color right away when you just have the blueprint. And the driving modes of the car. So for example, it will have the methods. So in this case, for example, you will have the driving modes in the car. So I hope that's clear. If you have any doubts, yeah, you can unmute and ask. So basically, these are what objects and classes are. This is very similar to what you would see in real life. Is there any doubt? Okay, fine. Right, I think I'll move on. Okay. So yeah, like I said, classes are blueprints for making objects. And the classes are useful in a way because you can bundle different types of data together. I mean, you can have an integer type data, or you will see in a bit when I show you the code. You can have string type, or you can have any type of data, and you can bundle it together. And each variable is known as the attribute of the class. So attribute, say you have you have a blueprint of a car. Some of the attributes will be the color of the car and the tires of the car. So they will be in the blueprint, but when you actually make the object, you will have to pass in the values of the attributes. All right. So this is the syntax for making class. So we'll have class, my class, and say my class is the name of the class, and class is the keyword, and statement that you use, say x equals 5, and we make an object out of it. This is how we make an object out of the class. And as you can see, this object will have an attribute that is predefined in this case. In this case, it is predefined. The value of the attribute is predefined and it is equal to 5. But you need not always, like I said, when you build a car, you won't have the color right away in the blueprint. The color that you're going to paint the car, that you won't have it in the blueprint. Finally, when you make the actual the body, the tires and all, then only you will paint. So then only you give the color. So yeah, that's what I mean. So in this case, we have given we have initialized already. But say you want to give the values only when you make the object. How will you do that? So we use something called constructor, init constructor, and that is used to as the word init. It stands for initialization or something. So yeah, init constructor. You can use this. It's a function that comes under this class. So you can use this function to give values to the attributes. So let's take a simple example and say let's use a blueprint, and that is pen. Pen is a blueprint here. It's not the object. So here I have this init function. And this is a function that takes 3 parameters. So self, color, and tip. And yeah, I'm not sure if I mentioned here. So we use this something called dot, if you observe. This dot is to access the attribute of the object. So let's say we have self dot color equals color. So what this means is the here self is the object that we're referring to. So when you make an object out of this class, that object will be referenced by this keyword self. Self is a keyword here. You can also use any other word, but that word, if you use another word, you have to stick with it. So here instead of self, you have to give another word. And yeah, so that's how you define the attributes of the pen. And like I said, you can also have methods because objects can also perform something, right? So like I said, the car can move. So here we can write something with the pen. So let's say we define a function write. And so again, even for methods, you have to pass in the name of the object. And that is referenced by self. And again, the statement that we have is separate. So this is a function that we have seen previously. Something like it's a function. Yeah, so that's how we create a class. Now, to make an object out of the class, what you do is you give a name to the object, and you initiate like this, just like a function. But here, it works in a slightly different way. So yeah, so here you give pen, the name of the class, followed by the values of the attribute that you want to give. So here, if you give red and iridium, the red goes to color, and the iridium is an argument for the parameter tip. So which means self.color equals color. So yeah, this can be slightly confusing. I'll simply just quickly change. Yeah. Yeah, so here pen color is the attribute, and that will take the value color that which we give outside the function. So here we pass it red, that will become the attribute value of the attribute pen color, and iridium will be the value of the attribute pen tip. And yeah, so and to again, like I said, to access this, you use a dot operator, and you can also access the method of the object, that is the function it performs, using the same dot operation, except that you will give brackets. So I hope I'm clear. I'll run the program. Okay, so yeah, sorry, I made a mistake. Yeah, so the name of the attribute is not color, it's pen color. So I have to give pen color and pen tip. Fine, yeah. So yeah, so you can see outputs are red, iridium, and right something. So I hope it's clear. And if you want a clear understanding, I have given another example, and you will be provided this notebook after the session, so you can go through this example to make your understanding clear. And yeah, so now I'll pass it to Ashish, who will explain you about lists and the other data types that are available in Python.
Yeah, so regarding that, so since we are already out of time, so what we have done is we have uploaded it to the GitHub repository. Okay, so you can, if you are interested and curious to know more about this, you can go check it out. So I think it was shared to you on your email yesterday. So there's not a lot of things to learn there. It's just like continuation of what Anirudh had mentioned in the start. Okay, so I hope that is fine. All right. So I guess that is the end of today's session. We have Monday session, that is introduction to C++. It will not be exactly similar to your CS 1100. This will have a bit of competitive programming touch to it. So like be sure that you attend that. That will be held offline hopefully. So we'll anyway send you a mail regarding that. Okay, please stay tuned.